Hey guys, this is Faizan and welcome to today's session on solving coding interview problems from top MNCs. Now, before I start, can you guys quickly confirm in the chat if I'm audible or not? Is everything okay? Can you see me? Can you see the pointer? Can you see the slide deck as well? If yes, then give me a quick confirmation so that we can get this session going. Just write a yes or no in a chat. While we wait for others to join, let me give you a quick tour of how our academy looks like. So just type in Grey Learning Academy. Here's the link. Just click on it. This will redirect you to this page. Now here, if you scroll down, you will have all the options of all the courses, that free courses we have. Okay, if you are looking for something that is an IT and software, we have data structures and algorithms in Java, right? We have Java programming, we have cyber security. All of these courses are absolutely free. HTML, CSS, blockchain. Okay, and if you're looking for something that is in Hindi, you can also check out these courses that are there. Python in for machine learning, or we have Python programming in Hindi. All these courses are absolutely free. Now if you're looking for a career transformation, we also have PG programs associated with it. Okay, so if you look at the popular courses, these are our popular courses. Now if you're looking for something that is explicitly in software development domain, we have affiliations with these. We have courses along with IIT Madras, we have Triple IT Hyderabad, and we also have MCA degree program. Okay, you guys can check it once the session is over. Okay, and if you're looking for the details where you can find all the sessions that are there, just scroll down and you will find out here. Okay, these are the upcoming live sessions, and if you want to view all the live sessions, just click on this button. Okay, and for getting a completion certificate, you have to answer 6 questions correctly out of 10 in order to get that certificate. Okay, cool. So now, okay, I can see some yeses. Okay, great. So now let's get started with this session. Okay, so if you have any confusion, just write it in the chat. If I'm looking on this side, that means I'm monitoring your chat. So anything, it can be anything. Okay, so cool. So now let's start with our first problem. We'll start with a simple problem and see how companies ask questions around this domain. Okay, around this problem. Okay, so we all know about this series, that is the Fibonacci series, right? You have 0, 1, and then we have 1, 2, 3, 5, 8, and so on. Now can anyone tell me what is the recurrence relation for this series? Sir, I am from commerce background, one of machine learning engineering, and do machine learning courses. Will company consider shortlisting my resume? Yes. Obviously, you need to add some projects, Lokesh, as well. Okay, you need to add some projects here and there, and in order to show that, okay, you are okay, so you need to show the courses or anything, the like an application that you have learned this and you have built this. Okay, some simple applications, and that too on your own. So in order to justify that, you okay, whatever you have learned, you have implemented it. Okay, so cool. So can anyone tell me in the chat what will be the recurrence relationship of this? I can give you a hint that if for this particular number, this is deduced from the when we add this and this number is deduced, this number in this series 2 is reduced from when we add the numbers this and so on. Okay, from the in nutshell, you can say that 2 is obtained by the sum of its previous number, and that is, if this is n, then we can say that the previous or the next number will be n minus 1 and the plus n minus 2. Okay, quickly, can anyone tell me the recurrence relation? Okay, so let's start with the recurrence relation and let's see the program. So the recurrence relation is that what is the, so obviously when we talk about recursion, we know there are 3 things in it. What first is the base condition, which obviously we should have a base condition, meaning that yeah, a is equivalent to b. No Manju. Okay, not a is equivalent to b, basically n is equivalent to n minus 1 plus n minus 2. Okay, so now what is the base condition? Base condition, okay, a equal to b, b equal to c, c equal to a plus b. Okay, so a equal to b, b equal to c. Okay, Manju, so you can just simplify it, right? Right, a and b, a equal c is equivalent to a plus b, right? And this a is nothing but your n minus 1 and b is your nothing but n minus 2. Okay, Manju, so cool. So now if you talk about recursion, there we know there are 3 things, right? Base condition, self work, and the recursive call. So you see the self recursive call here and the self work that we do over here, and this is the base condition. Okay, base condition means that, okay, if you don't have this base condition, then the recursion will never know when to stop. Okay, So this is very important. Okay, now with the help of this, we will be able to obtain all the series. Let me do a dry run. Okay, so if you observe this, so let's pass in n. Okay, sir, I am mechanical background, so do I need any basic knowledge to enter in software domain? um, Mechanical, so obviously now one thing, sir, first you need a programming language, so with which you can just code anything and create function, create games or create websites, right? You need a function, right? Yes, Shubham. Basically, we will be dealing with questions that are asked in Amazon, some Facebook questions, and some simple questions. Right? I will show you the next question that is asked in Amazon, which is based on something which we already know. Okay, so just wait, and these questions are asked by other companies as well. So let's say TCS, Wipro, because they just copy the questions, right? Okay, cool. So now what happens in this, let's try to do a dry run. So let's suppose I gave you a number 5. Now what you are doing, now I told you that I want to find the fifth Fibonacci series that is there. Okay, fifth number that is present in the Fibonacci series. Okay, so now what you are doing, you say, okay, this num is less than or equal to 1. Now what you will say, okay, is this num less than or equal to 1? No, it is not. So this will never be executed. So now what happens, this fib5 that is there will call two functions. These two functions will be called, and there will be a plus sign as well. Okay, so you will call fib4 and fib3, right? F, or you can just remove the ib. Okay, cool. So now what happens, now this will remain as it is, but now we will focus on this. Okay, so again this will be called, then again this will call. Okay, it will check, fib4 will check, is this number less than n? No, it is not, right? And then what it will do, it will again call fib3 and fib4. Okay, then again this fib will call fib2 plus fib1 and so on. Okay, so with this, what happens at the end when we are at this particular call? Okay, so what happens, this will be fib1 plus fib0. Now this number is equal to what? It is equal to 1, so it returns num, that means it returns 1. Okay, number is 1. Similarly, this will return 0. When we add these two up, it will be 1 and it will be returned to 3. Similarly, what happens in fib1, it will be checking, okay, this number is less than or equal to 1. Again it will go back, and what happens over here, now before we send it, we just add these two. So 1 plus 1 is 2, so this will be sent to 2. So 4, we have already calculated the 4, what it will be. So it will be again fib3 plus fib2. So if you observe carefully, we have calculated the fib3 value, which is 2, and fib2 is nothing but 1. So 1 plus this will be again 1. So this will be 2 plus 1, this will be 3, and fib4 will be 3. Okay, then again these two will be added up, and this will be sent to this function, which is 5. And fib3 we already calculated, it will be 2 plus 3, that is not 2 plus 3. So let's calculate fib3. So fib3 is nothing but fib2 plus fib1. Okay, so fib1 is 1, and 2 we already calculated, it is also 1. So 1 plus 1 is 2. So we will be returning the value as, so this is 2, so we'll be returning a value of 8. So now if you observe carefully this tree, what is happening over here, so basically this is a simple question, right guys? So basically we are calculating the we have already seen this. Whenever you learn anything, the first thing that you learn then to talk about is the Fibonacci series and the factorial program, right? So now keeping this question in mind, you see, keeping this question in mind, what we are going to do, we are going to see how we can use this in solving some different problems. Okay, so now let's see the problem number 2, which is based on something that is already, we have already seen it. Okay, so now this was asked in Amazon. Okay, now let's see what is this question. This question is very simple, guys. So now focus. So number of binary strings without consecutive ones. So you need to find out, if n is given to you, right, you need to find out the number of binary strings. So we know if n is equivalent to 2, that means you will be having inputs 0 or 1. For A and B, you can have 0 and 1. So if you there are two, if n is equivalent to 2, that means you can have, A can have 0 value, B can have 0 value, A can have 0 value, B can have 1 value, A can have 1, B can have 0, and A can have 1 and B can have these values. So if you observe carefully, these are the binary strings that can be formed with the help of this n. Function f4 will call function 3 and 2. Yes, n minus 1 and n minus 2. Okay, so now what happens in this? So basically you need to find out the number of strings that are there without consecutive ones. So in this, what will be the answer if n is equivalent to 2? So this will be considered because there are no consecutive ones. This will be considered, there are no consecutive ones. This will be considered, there are no consecutive ones, and this will not be considered because there are consecutive ones. So the answer will be 3. Similarly, if you go for 5, so what will be the answer? It will be if there are 3 inputs, right? So 0 0, you will say 0 0 0, then 0 0 0 1 1 1 1, then 0 0 1 1 0 0. So you know how to create a truth table, right? So 0, then 0 0, and then 1 1. Okay, so then 0 1 0 1 0 1 0 1. So these are all the list of possibilities that we can have if we have n equal to 3. So now here we have, this is the answer, this is our answer, this is our answer. This is not our answer because we have consecutive ones over here. This will be our answer, this can be our answer, this is not because we have consecutive ones over here and we have consecutive ones over here. So our answer will be 5. Now quickly, can anyone tell me what will be the answer if n is equivalent to 4? Quickly, just write it in the chat, anything. So we have n equal to 2 and n equal to 3. So we have the values as, let me just clear my screen. So when n was 2, we had the answer as 2. So answer is 2, right? Not 2, answer is 3, right? When n is equivalent to 3, answer is 5. Now can anyone tell me what will be the answer when n equal to 4, when n is equivalent to 4? Quickly guys, you need to understand what I'm trying to do here. So quickly think about it. Just write, create a truth table for now. So what will how would be our truth table look like? So let me just clear my screen and use a different pointer over here. So our truth table is, we have right now we have n equal to 4. So we are talking about 0 0 0 0. So now we have 4, so these will be 8. So 0 0 0 4, then 5 6 7 and 8, 1 1 1 1 1, 8 ones, and so on, right? So this will be 4 zeros followed by 4 ones, right? Okay, Manav says 50. Yes, we have total number of possible combinations, we will have 15. Okay, so now this will be 0 0, this will be 1 1, and then try to find out the number of ways, number of that the possible answer for n is equivalent to 4. Let me give you a hint without calculating it. Yes, it will be 8. It will be 8, guys, not 7. Carefully think about all the possible options. It will not be 7. Yeah, Indranil. Yes, correct. It will be 8. Now, if you observe carefully, does this pattern look similar to you? So basically you have n equal to 2, your answer is 3. You have n equal to 4. You have n equal to 3, your answer is 5. You have n equal to 4, your answer is 8. If you have n equal to 5, you will be having answer equal to 13. So if you observe carefully, this is something that we already covered. What is that? This is your nothing but your Fibonacci series, right? So basically you are adding these two up, you are getting this value. You are adding these two up, you are adding these two, you are getting this value. You are adding these two, you are getting this value. So same, you see. Now the question will not be asked to you directly. So give me a factorial of this number and give me the answer. No, it will be asked in this manner. Okay, there are almost 7 to 8 questions that follow this pattern, the same pattern that we have already seen, the Fibonacci series pattern. Okay, so now if you see the program of this, so you see now you need to just manipulate your base conditions. That's it. Okay, for n is equivalent to 0, or if n is equivalent to 1, you will return 1, else you just add them up just like we have seen. Okay, so these now you see, observe carefully. If this is one of the this is one of the way. So if you're not comfortable with this, because here now what I'm doing, every time when n is equivalent to 3, when we are trying to find out if n is equivalent to 3, what is the function call that I'm using? I'm using the function call of n plus 2. If you're not finding this comfortable, yes, 8 is the answer. Okay, so for 8 you have n equal to 4. If you're not finding this comfortable, what we have another way with which we can do it, that is the implementation 2. So what I'm doing over here, if n is equivalent to 0, return 0. If n is equivalent to 1, return 2. If n is equivalent to 2, return 3. Now these are my base conditions. Now after that, I will be adding them up, right? That's it. I'll be adding n minus 1 plus n minus 2. Rest of the cases which are not following along, I will just add them as a base condition and done. So every time, now the slide deck will be shared with you guys, so don't worry, okay? So every time when we have this scenario, I'm just adding these two up, and we have the base conditions, I am adding these two up. Like we have seen, this is nothing but your Fibonacci series recurrence relation, right guys? Okay, is this thing clear? Are you following along? No problem, no problem technical. You just give yourself time. If you're familiar with any programming language, just look at the questions, okay? Just look at the questions, and then maybe after the session is over, you just if you don't have any knowledge regarding any programming language, this is something that is independent of programming language, even if you know C, but I would rather suggest you to go for either C++ or Java if you're trying to code, okay? If you're looking for something that is related to CP or competitive programming, okay, you should definitely go for either C++ or C. I want to learn coding, sir. Okay, I want to learn coding. Okay, so this is what we are trying to do here, okay? Cool. So now what is happening? What is happening over here? So basically, is this thing clear, guys? Sir, can you repeat? Please repeat. So Pramod, what I'm trying to say. So basically, we know we have already covered the factorial part, right? So now we have this question wherein this follows. We are trying to find the number of ways with which we can have when n is given to us. We want to find the number of consecutive ones. Okay. So now without we want to find out those regularly. This live session goes on. Yes, Nikhil, but not explicitly every time we go along with these sessions. We have different sessions, okay? Different range of sessions is there. So basically, which includes front end, which includes back end, SQL, Python, machine learning, okay? So we have a different range of sessions that will, every day there is a session. There are two sessions, one at 2, one at 12 p.m. and another at 4 p.m, okay? Cool. So now what is happening in this, we want to find out all those possible numbers or all the possible combinations, except we have Abdullah, we have courses available on data science as well, okay? So you can check it after the session is over, okay? Will you suggest Python for coding interviews? Not really, but if you are in your third year or fourth year, then I don't want you to waste your time in learning something new. I want you directly to focus on the data structures and algorithms part. So in that case, I will suggest you to stay with the Python. If you are in first year or second year, then definitely Java or C++. Now Java is a safe option because we have a bunch of legacy code that is written in Java, so there will be job opportunities available in Java as compared to C++. Okay, cool. So we want to skip these numbers which are having consecutive ones, except and rest of the whatever are the rest of the things that are there. Sir, explain. Lakshmi, maybe I will try to cover that at the end. Basically, I have a bunch of questions with which we can solve maybe around. I will explain one question. With that one question, there will be almost 7 questions that you can solve, and with one more question that I will be showing you in this session, you can solve almost 15 questions based on that. Okay. Okay. Cool. So now we want to find out without this 1 and 1, the consecutive ones, we want to you want to print or find the number of numbers that are there except the where you have these consecutive ones. So the first approach was that we have already covered Fibonacci series. Then what I'm doing here, at the end I am just passing in whatever is the value, I just increment it by 2. So basically what I'm doing, I'm skipping these two terms, okay? Smartly. But if you think that this is something that you're not comfortable in, so you can go for another approach. So that is same that in here what I'm doing, I'm just writing these base conditions, okay? If n is equal to 0, return 0. If n is equal to 1, return 2. If n is equal to 2, return 3. So once I do this thing, then it is same as Fibonacci series, and you don't need to explicitly do n plus 2 over here. Just pass in whatever is the value, okay? Cool. Now let's look at the question number 3, or the problem, that is third problem. Now this is the question, right? So count the number of ways to reach the top. You can take either one step or 2 steps. So let's suppose you have a stair, right? And now you are at this position, okay? So you can, how many steps are there to reach at this position? You can either take 1 step or 2 steps. Here you can only take 1 step, right? uh, Rishabh says, I asked your previous question also same, then the scope, okay. You don't make any videos if someone have a gap and if learning Java. No, there is no such thing. I am learning Java. Yes, you can code in Java, Rishabh, so don't worry, okay? You can code in Java as well. So there is no such thing that we don't, if there is a, if you don't make video if someone have a gap. By gap you mean that there's a year gap, right? Yes. There is no issue in that. You can just go ahead. It all depends on how how your coding skills are. Okay, you just have pick a language and then just start coding. Okay, there is no such thing that if you have a gap of 2 years or 1 year, there is no issue in that. Okay, and there is no such thing even for the companies, right? Start date and Flutter basic series. Sure. Please start a day. Okay, Supriya. Sure. So now what is happening? What you can take either one step or two step. Here you can only take one step. So the number of ways that you can reach at this position is one. So that is why input is one and your output will be one. Now if you have, but I have a gap. No issue, Rishabh. Okay. Now what you have, if you have two stairs, okay. Now one way is to go one and one, that is a one way, or you can go directly. You can start from here and take two steps, and you can take two steps at a time. So one way is one and one, another way is two. So if you have n is equivalent to 2, now sure. If you Abdul, if you want to become a full stack data scientist, so we already have sessions. You just start one by one and then look for the best possible option. Okay, I have 4 years of gap. Okay, you have 4 years of gap. Then in that case, what you have to do, you have to make your resume very strong, Rishabh. In that case, you should have obviously, now along with the coding skills, you need to add projects. Okay, you need to add a lot of projects because preparing for work. Okay, no problem. You need to add a lot of projects. You need to add simple projects as well as you can go for complex, okay, or complex projects. But you need to have something to back your resume, right? So you need to add more projects. You need to add skills. You should be a complete package because your 4 years gap is a lot. Okay, so in that case, you have to work really hard. Okay, cool. So now what is happening? Now if we have four state cases, okay, if n is equivalent to 4, now what happens? If n is equivalent to 4, what is happening? So let me just rewrite this in again. So you have 1, then you have 2, then you have 3, then you have 4. So the first way, sir, please reply my question. Abhishek, what is your question? Sir, I am a mechanical engineering student in 3rd year. Which language is best for me? So do you have any prior knowledge? Do you know any language, like do you have a language that you already know? Then I can suggest you to go for that because you are in 3rd year. Suvita says, wow, Fibonacci 5 is 8. So Fibonacci of 5, how is it 8? This means the 5th number in the series. Okay, so if I go back to the problem, right? So you see, these two numbers are not, this is your 5th number, this is your 4th, this is your 3rd, this is your 2nd, this is your 1. This is not considered, okay, when you are looking for the 5th number in the Fibonacci series. Okay, Suvita. Okay, so also this depends on the question to question, right? If someone is asking that, it will be given to you, right? You have whenever you are coding, it will be given you. If input is 6, you have a Fibonacci. If the answer is, let's suppose if Fibonacci, if the question is given in this way, that you find the sixth Fibonacci number in the series, and answer is given 8. If it is written in this way that 6th number is 5, that means he is considering this 0 as the first. Okay, it depends on question to question. Okay, it depends on how they are asking you questions. Okay, there is no such rule that okay, this will be always the case. In here you can think of it this way. Okay, but if it is specifying explicitly in the question that the 6th term is 5 and not 8, that in that case he or that interviewer is expecting you to take 0 into consideration as well. Okay, I am intermediate in Python. Abhishek, in that case, can you implement data structures and algorithms in Python? So if no, then it is quite then you should go for Java. Okay, then you should go for Java. If you can implement, then stick to Python and start coding in Python itself. Okay, cool. So now in problem 3, what is happening? This is your staircase, and now if n is equivalent to 4, that means you have 4 staircases, and now what you are here. So you can take 1, 1, 1, and 1. So 1, 1 step, this is one way. You can either take 1 and 1, then directly 2 jumps. So this is your second step, second way. You can take first 2 jumps, that means you will be from here to here, and then 1 and 1. Okay. You can take 1, then 2 jumps, then 1. Okay, you can take 2 and 2 at the end. So the total number of ways is 5. Okay, so does this question ring any bell? Does this was asked in Google, guys? So this is a Google question. Can anyone tell me what is happening in this question quickly? When n is equivalent to 1, or you can say 1, the answer is 1. When n is equivalent to 2, answer is 2. When n is equivalent to 3, we haven't specified the 3, let's go for 4. When n is equivalent to 4, answer is 5. What will be when n is equivalent to 3? So you have 3 staircases, okay? This is a Google question, guys. So wait for it. So 1, 1, 1. This is one way. You can go 2 jumps and then a single jump, that is your second way. You can go 1 and then 2, this is your third way. So you have only 3 ways, okay, when your n is equivalent to 3. So what is this series, guys? This 1, 2, 3, 5. Can anyone tell me? Sir, could you suggest a language to learn because I am a beginner? Okay, Abhishek, okay, no problem. Okay, so I'm a beginner, I don't know how much about software field. So start with the language, guys. Start with the language. You have to start anywhere. If you don't know anything, just pick a language that you are comfortable in. Or if you can be smart in picking a language in such a way that you see, okay, in this language, even if I'm not going into tech giants like Google, Facebook, or Amazon, but still I can solve questions for other companies, like coding problems, then in that case you can pick a language and start implementing your data structures and algorithms. That will work. Okay, okay, Akram. Okay, so yeah, so now this doesn't have to be a permutation, Aishmat. This is again your Fibonacci series. Okay, no, not a prime, again a Fibonacci series. So the next number, if n is equivalent to 4, n is equivalent to, if there are 5 staircases, again you have 3 plus 5, 8 will be your answer. Okay, guys, so you see, this is a Google question, and what we are doing, we are implementing Fibonacci series. That's it. We are not implementing something rocket that you don't know. You already know this series, right? This series is already known to you. Again, this question was asked in Google, and the basic is same. Then obviously, then you have to apply some dynamic programming, which is something else. But that is nothing but there are serious problems with Fibonacci series. That means you are like I have shown you in the tree, right? That tree. If you have Fib 4, that you are doing Fib 3 and Fib 2, right? If Fib 3, for you are doing Fib 2 and Fib 1. For Fib 1, your Fib 2, you are calculating Fib 1 and Fib 0, right? But this 2 was calculated again and again. So that is the redundancy there, okay? So so in order to not calculate this again and again, there your dynamic programming comes into picture. So you will store these values in an array and then fetch it whenever you have this function call. That is something else. But the basic of this problem is again a Fibonacci series, right? Correct? Okay, so again you will see, if n is equivalent to 0, n is equivalent to 1, return 1, else n plus 1, n minus 2. Simple. And again I am doing some little bit of manipulation, so I am passing in n plus 1. Okay, so similarly you can change your base cases and go for a relevant answer. Okay, guys, is this clear? Yes, Ayushman, 13. Yeah, not yeah, same. Correct. This is your Fibonacci series, right? Can you give me a quick confirmation in the chat is if everything is going smoothly? Are you able to understand each and everything? Quickly, just write a quick yes. Then we go for the next question. You need to wait. Yeah, memorization. Yes. So you can skip memoization. There are two ways, right? Bottom to up and top down, right? So there are two ways of DP, Abhishek. So you can either go for memoization, and else you can go for some that is the bottom to up. Okay, quickly, just give me a quick confirmation, guys. Okay, cool. So I'm working which should have. You're working as a. Okay, cool. So now let's see another very important series, very important, guys. And this is almost 15 on recursion. On recursion, the not the recursion, on Fibonacci series, there are almost 7 questions that you will find. You will be able to find. Okay, but on this series, there are almost 15 questions that can be solved using this series. This is a very important series. This series is known as Catalan series. Okay, what are the numbers? So the numbers are 1 in the series, 1 and 1, then 2, then 5, 14, 42, and 132. So again, how we can find out this? So for 0 and 1, it is 1. So first Catalan number is 0, second Catalan number is 1, third Catalan number, that is C2. This is calculated in this way. So basically what you will be doing, you will be having this and this is multiplied with this is multiplied with this. Okay, this number is multiplied with this number is multiplied with this is multiplied with this. Okay, we do have sessions, right, guys? So start learning. I cannot help you with the internship kind, but I can certainly guide you so that you can get started in your machine learning. Okay, you can start coding anything. Okay, sir, which libraries are required to learn for machine learning? I have no idea, Omkar. So we have sessions on machine learning. So once we do take sessions, but Bharani is taking those sessions. So whenever there is a session that Bharani is taking, you can ask him. Okay, cool. So this number is multiplied with this is multiplied with this. Basically the previous numbers, and we multiply it in this way. Okay, so 1 is multiplied with 1, then we add them. So 2 is the second number. 1 1 1 2, these three numbers when multiplied in this fashion, what we get, 2 1 2, and this is your fifth number. Okay, so can anyone guess the recurrence relation? So this, I know this is a little bit tricky series, but yeah, can you try this Catalan series? There are almost 15 questions which are based on this. So they will ask you, find the number of ways with which you can, one person is doing this, one person is doing that. So all are dependent on this question, or on this series rather. Okay, quickly, can anyone think of this the recurrence relation? Quickly, guys, think of it. What can be the recurrence relation? I will show you, but I want to think of something, at least something, so that you know, okay, this was the thing that was missing. Okay, quick. Okay, now let's see the series. Okay, so basically what is happening in this series, how we calculate this is your recurrence relation. Okay, so this is your recurrence relation. What we will say Catalan series of I multiplied by Catalan series of n minus I minus 1. So this is the series. Try to dry run it. So let's try to dry run it. So I'm passing in cat 5, so I want to calculate the Catalan series. That means I want to calculate, this is, let me just clear this. Sir, how to use Java language? So we have courses available on Java on our YouTube channel and also on our Great Learning Academy. Try to go for the basics first, and then can I get a job knowing Python? Yes, you can, but you need to back up that Python programming, whatever you learned. You need to implement that you need to show, okay, this was the thing that I learned, this is the thing that I built. Okay, you need to show those things to the interviewer. Okay, knowing Python, everybody knows Python, but you need to show, okay, what did you do, what else did you do with this? Okay, did you create any games, right? Did you build any website with the help of Python? What else did you played around with the databases? Okay, so you need to show that to the interviewer. Okay, cool. So now if you observe carefully this series, so let's clear this screen. So 0 1 2 3 4. Okay, and this is your 5. Okay, so now the Catalan number is again 2, and so the output should be 5. So let's go for something that is simpler, that is 4. Okay, so let's go for 4. Okay, so our answer should be 14. So now let's go for this. Okay, so now we'll pass in 4 as an argument, not 5, so that we have less calculations to do. Okay, so 4 is passed. So we check, is this number less than or equal to 1? No, it is not. So we have this result that is there. Okay, so now what we are doing, we are traversing from 0 to n. That means we will be traversing from I equal to 0 to n. Okay, now what is happening in this, what we calculate the result. What we are doing, we have this result res. So let me just clear it again. So we have this result, and what we are doing, we are saying result plus cat of I. So cat of I, I, what is I over here? So I is 0. So we calculate cat of 0 multiplied by cat of, that is the Catalan series of n minus I. So n is 4, currently n is 4. We have passed in as not n, so it will be n. Okay, not num. Okay, n. Okay, cool. So n, and then what we are doing, n minus I. That means 4 minus I, which is 0, minus 1. That means 3. Okay, so cat of 3. Why we are doing this? Remember this picture earlier which I showed you. 1 1 1, and then 1 1 1 1 and 2, and 1 1 and 2. So the first number is multiplied with the last number. So this is, I didn't get the Catalan series. Ashish, what is Catalan series? So remember, so this is how you figure it. Okay, so basically what is happening, this 1 and 1, when you write it twice over here, then if this number is multiplied with this and this number is multiplied with this, so basically what is happening, 1, the Catalan series, that is the 0 Catalan series, is multiplied with the last. Same goes for this, the last one is multiplied with 1. Okay, so same thing we are trying to do it over here. So they see 0 is multiplied with 3. So 0 is multiplied with 3, right? And then whatever is the sum, right? So Ashish, is there any fundamental for a Fibonacci series? No, right? It is just a series, but you just calculate. Okay, how we calculate this series? Basically. How you calculated the Fibonacci series, basically you are adding two numbers and then summing it up, right? So same series, this is one of the series, the Catalan series, in which the 0th number is multiplied with the third number. Okay, once this is done, we calculate the result. Okay, so let's try to even simplify it. Let's pick a n is equivalent to 3. So in this, what happens, 0 to 3, and then it will be multiplied with 0 and 2. So you know that what is your Catalan series of 0? You will call this function at Catalan 0 will be called. So Catalan 0, it is less than 1, right? So 1 will be returned. So you will be having 1 over here, 1, you will find out 1, and then what is happening? The next thing, the I will be incremented. Your I will be incremented. When I is incremented, it will go to 1. So now this time around, what is happening? So after this, what will happen? So this will be called, and Catalan series of 2 will be called. So what will happen in the next iteration? So 1, and it will be result plus Catalan series at 1. So 1 will be multiplied with Catalan series of n, that is your 3, minus I, which is 1, minus 1, that is Catalan series of 1 again. So 1 is multiplied with 1. Okay, right? And then finally, when n is equal to 2, it will be 2 multiplied with 1. Okay, now I changed it to, when I changed it to 3, so it will be here, it will be over here 2, right? It seems that more of from data science analytics. No, it is pure mathematics, guys, pure mathematics. So you need to understand how you are doing this. Okay, so basically what we are doing, we are multiplying the top number with the bottom number in the same series. So basically, what is your series? 1 1 2. So what you did, you calculated 1 1 and 2. What you're doing, you're writing it twice, and then how you are adding it, this number is multiplied with this number is multiplied with this number is multiplied with this. Okay, that's it. This is how you find out the next Catalan series. Okay, so now once, guys, it is very I know this is too much to handle right now, right? You don't know this series. You need to understand one thing, that you need to do a dry run of these kind of series. Okay, in order to understand what is happening, do a dry run, create a memory map. I don't know nowadays, do you guys know what a memory map is? So basically, what we used to do when we used to basically we used to call dry run as memory map. Okay, so basically what how this function is operating, what is the value, all those things were calculated in this fashion. And then we had this result, then we had this what cat series of what is happening over there, create a memory map, or you can dry run it. So once you are dry running it, you will be able to find, okay, this is the series that is generating. Okay, so now once this series is generated, this is the solution of that, right? Now how you can implement this? Basically, there is a question, very simple question, you can say. I told you guys that given a BST, there is a BST given, right? And in that BST there are two nodes. Okay, now you need to, there are two nodes, so let's suppose 5 and 7. This is the BST that is given to you. So you need to tell me how many trees are possible with these two nodes, but keeping this thing in mind, all of them should be. Can you show this in Python? I don't know anything about Python, Anurag. Okay, I am moreover into Java, C++, or and JavaScript. Okay, so basically now how can I create one BST can be, you have this 5 and as the root and 7 as the on the right hand side. Another BST can be you can have 7 at the top and 5 on the right hand side. So when you have if you want to create a BST with two nodes, those two nodes can be anything. Okay, you can have two there are two BSTs that you can create. Now if I give you three nodes, right? One is 5, another is 6, and another is 7, anything, right? So what you can do, first BST can be 5, 6 and 7. What is the second BST? You can have 7, 6 and 5, right? You can have 6 in between and 5 over here and 7 over here. You can have a 6 on, or you can say you can have a what else can be there? If you have what you say, if you have a if you have a 5, and then you can have a 5 over here, you can have a 6 over here, and what else can be there, guys? Can you think of any other BST that can be formed quickly? So is there any other way or any other BST that you can form with these nodes? So what is the basic functionality of a BST? How do you create a BST? So basically you have a root, and on the left hand side of the root all the elements will be less than root, and on the right hand side all the elements will be greater than root. Okay, so if you have 5 at this place, and if you have 6 over here, then you can have 7 over here. Can you think of anything else? 5, 7, 6. Yes, correct. You can have 5, and then you can have yes, Ayushman. So you can have 7 on this side, then you can have 6 on this side, right? And also there will be one more BST is possible. It can be 7, then if a 6 will come be on this side. No, this is already done. There will be one more BST possible. Can you think of anything else, guys? Quickly. 5, 7, 6 is done. There will be one more BST, I am for sure. Can you think of it? 5, 6 and 7 already done, Rahul. This is your 5, 6 and 7. This is your 7, 6 and 5. This is your 5, 7 and 6. Anything else? Quickly, guys. 5, 7 and 6 already done, Ravi. 5, 7 on right, 6 on the left. 5, 7 on the right, 6 on the left. Done, Ayushman. You have here 5 on the right. Okay, so one more BST is possible, that I'm sure. 6, 7 and 5. Okay, let's see. 6, then you have a 7, and then you have a no, this is not possible. So Fatima says 7, 5 and 6. 7, you have a 5, Okay, and you have a 6, correct, not a 6 over here, so 6 will be on this side. Yes, so in total what I'm doing, so JavaScript lectures are available on Great Learning. Yes, Nikki, so there is a complete tutorial of 10 hours and 26 minutes to be precise, so you can check that. Okay, so the total number of BSTs right now, let me just clear my screen and let me show you. So one, if you have n is equivalent to it is on our YouTube channel. Okay, so done, we are done. So only 5 will be there. So if you have 2 nodes, the answer was 2. If you have 3 nodes, the answer was 5. Can anyone tell me what will be the answer if n is equivalent to 4? It will be 14. Okay, so again, if you observe carefully, it will follow this Catalan series. Okay, so if n is equivalent to 2, and answer will be 2. If n is equivalent to 3, answer will be 5. If n is equivalent to, if n, one second, so if n is equivalent to, where was I, yeah, if n is equivalent to 4, answer will be 14 BSTs are possible. So now this was again asked in maybe I guess it was asked in Walmart or something, right? I don't remember exactly, but it was following this simple what Catalan series. Okay, 6 7 5 is not possible. 6 7 and 5, this is not possible, right? No, Mahadev, this is not possible. So you can have if you want to if you want to insert a 5, so it should be on this side, so which we already covered, right? If you, so just remember this thing in nutshell, that whenever you have n is equivalent to 3, there will be only 5 nodes that you can create, 5 BSTs that you can create. You can try it out, it is tried and tested that this problem will follow Catalan series. Okay, is this thing clear, guys? You see now how things are now. Not only this, not only BST problem, there are almost 15 to 20 problems that follow this pattern. Okay, so they will ask you some fancy question and tell you to calculate the number of possible ways, so you don't need to go into permutation and combination always. So first look, okay, is this following this Catalan series? Because this is a very important series, guys. So think of this series as what, as the first approach whenever you are asked to solve a particular problem and they ask you to find the number of ways, and same goes for Fibonacci series. Okay, is this thing clear, guys? Quickly, a quick confirmation in the chat. Can't we put that 5 on left of 7? So Aishman says, so you have earlier, okay, what was this? Okay, you're saying can't we put this 5 on the left of the 7, but this doesn't follow, right? So on the this root, it says that everything on this side will be greater than this, but you are now will be less than this root, and on this side it will be greater than, but this number is not greater than root, so you cannot do this. Okay, okay, Aishman, is this clear for everyone why this tree is not possible, why this BST is not possible? Because BST, binary search tree, follows this pattern that no matter what you do, the 6, if 6 is the root, then all the elements on the right hand side will be greater. Okay, okay, great. So now let's look at the fifth problem. Okay, so yeah, fundamental, you mean why this series? So basically this series is a mathematical series, right? So you just need to understand, okay, if you want to understand how it is happening, so in the same way, right? Is there any fundamental for Fibonacci series? Ashish, is there any fundamental that you think of for a Fibonacci series? If yes, then follow that same thing for Catalan series as well. If no, then you just try to visualize this in this way, that what is happening, and try to dry run this problem as many times as you can, so in order to get the hold of this series, and so that it is easy for you to implement in different questions. Okay, okay, so the longest subarray with sum equal to k. Now this question can be sum equal to k, sum equal to 0. Longest can be replaced with shortest subarray, or subarray means contiguous. Okay, so it should be one after the other. You can say now, you cannot, now if in this case the sum, let's suppose sum is -1, so Okay, sum is -1, so there will be no such array, so we are returning -1. Now in this case, if k is equal to 4, so that means the sum is equal to k. You need to find the longest subarray with sum equal to k. So the output is 5. So the length of that longest subarray is 5. So let's look at what will be that longest subarray. So basically, if you think of this as your longest subarray with sum equal to 5, right? So what will be the subarray? So you have a sum equal to 4, right? So and the value is, so if you think of this subarray that is there, what will be the length of this? 1, 2, 3, 4 and 5. So you are adding 1, you are removing it, and then you have 4. Okay, so this is your longest subarray with sum equal to 4. So 1, 2, -1, 1, 1. Because this is -1, so the sum will be this and this will cancel out, and this is the longest subarray. Okay, is this thing clear? But not getting for Catalan series. Yes, there is for BST. No, BST, it is clear, right? So, but Ashish, I'm saying that, are you following any, is there any fundamental for that, what you say, Fibonacci series? Right? If yes, tell me about it. Then we'll figure out, is there any, can we think of any fundamental behind the Catalan series? Okay. Cool. So now let's look at the solution. Okay, so basically there are multiple ways you can do this problem, but one of the way is that you create a hash map, and in that hash map what you're doing, first you calculate all the sum, right? You calculate all the sums that are there, and you add all the numbers. So you, once the addition is done, what you can do, not all the numbers, and now basically this is your sum, right? And what you're doing, you're adding one by one, you're adding the numbers. Okay, so since we have only 10 minutes left, what I will do, this is not that this is asked in the reason behind this problem is that this is asked, this can be asked in various formations. Yes, Kashyap, this can be asked in various formations, like the shortest, the biggest, the longest, the smallest, sum equal to k, sum equal to 0. So there are multiple variations. What you can do, just go iterate through it. It's simple guys. Just iterate through it, whatever is written on this code. Just try to dry run it and find out the way how we are doing it. Okay, but this is very important problem, I want to cover this. Okay, this is not the longest, right? The length of this is only 3. You are getting the 4 as your output, but this is not the longest, Ravi. Okay, the longest is with sum 4. Okay, yes, Ashish, so you are just adding the previous two values. Similarly, what you are doing, you are multiplying one by one. So this is something that happens in Catalan series. Okay, so now this question is very important, and this is asked in multiple, there is a lot of variations of this problem. Okay, this is asked by Amazon multiple number of times, and but just by changing the wordings. Okay, so ropes are changed with something else, petrol or anything, right? So this can be asked in multiple ways, and this is a very important problem. So let's try to cover this first, and then if time is there, we will go back to our previous problem. Okay, so now what is happening, so you have to minimize the cost of connecting the ropes. So these are your ropes, right? This is of 2 units, this is 5 units, 4 units, 1 units and 7 units. Now you want to minimize the cost of connecting the ropes. Now what is the cost? If you pick this unit and this unit, so you are picking the two minimum, you are minimizing the cost. So basically your cost is now 3. So now once you have this minimum elements, you have picked these minimum elements. Now whatever you're doing, what you are saying that, okay, now we have these minimum elements, now you're minimizing the cost. Okay, so this is the cost. Okay, and you want to combine them in such a way that you are minimizing the cost. Okay, so how I did it, how the logic is that first pick the two minimum elements in the array. So now add them up. So this is your cost of connecting the ropes at this particular time. Okay, yes, the 5 is the length of the subarray, right? So your output is 5, right? See the output 5. This is your length. This is the sum. K is sum. Okay, Kashyap? Okay, you were explaining Ravi. Okay, cool. So now you are minimizing the cost. So now what you did, you again inserted, because still now these two minimums are these were two minimum, but still you have this rope. So you inserted it back to your subarray. So you have now this is the array. Now again you pick these two minimum elements, right? You pick these two minimum elements and then added them up. This is the cost, 7 is the cost, so this is 3 cost, then 7 cost. Okay, Then what you did, you added them again into the subarray. Now again you pick 5 and 7, you added them, that is 12, this is the cost, and 12 and 7 at the end. Now these are the two left, so you pick up this 9, you pick up these two ropes and combine them. This is the cost is nothing but 19, and now you have a one complete rope. You have connected all the ropes and all these ropes and the sum, and you have to calculate, you need to minimize the cost. So the minimum cost is 41. If you would have picked in any other order, this will not, there will be no such value which is minimum than this 41. Okay, is this thing clear, guys? Is the question clear? Guys, is this thing clear? So I am minimizing the cost in such a way. Okay, Ashish says I didn't get it. So Ashish, I told you to this is the array given to you, but this array contains cost. Okay, now this is the cost, and I told you please connect all these ropes, and this is the cost. This is the cost. This 25417 is the cost, right? And I told you I want you to minimize the cost, and cost is nothing, and while connecting the ropes. So how you can connect these two ropes? So if you would have picked these two ropes, so you calculate it as 7. Okay, then you have this 7, 4 and 1 and 7. So you picked up what? Is there anything I'm missing? 1 2 5 4 1 7. Okay, so now you added these two, this is 11, right? And now what you did, you added them and then you inserted it back, so it will be 1 7 and 1. So there is something I'm missing. 2 5 and 1. Okay, let me just clear out my screen. Okay, so Ashish says I didn't get it. So what I'm doing, so what I'm doing over here, I have to minimize the cost. Okay, so what I'm doing, I am just picking up these two elements, the minimum two elements, and then what is the value? This is 3. Okay, so now in our subarray, what will be the elements? So it will be 5, 1 4 5 and 7. Okay, now the cost is this. Now you picked up these two elements and added them. Now you connected these two portions. Now you have only 3 portions. Okay, so basically you have these 5 ropes. These are the 5 ropes, and this is the cost of connecting them. Okay, 1 4 and 7. So what you did, you have to connect these, but you need to minimize the cost. So the one way you can connect it in any ways, right? So if you are connecting these two, the cost will be 7. If you are connecting then this 7 and 7, right, the cost will be 14. Then you are connecting, then you are inserting back this 14 in your array, right? Okay, so now then you're inserting back this 14 in your array, and then you have what, 4 and 1. Then again you have this cost associated with it, and again this 4 was missing. Okay, so now if you do any kind of these things, right, any pattern in which you want to add them, the cost will be always there. So now basically what is the cost? Cost is nothing. When you added this will be the cost. When you added this 7 and 14 with this, 14 will be the cost. When you added 14 and 4, 18 will be the cost. When you added 18 plus and 18 and 1, then 19 will be the cost. So 19. So this is the total cost. Okay, now if you're doing it in any other way, right, any other way apart from the way which I have showed you, picking up the minimum, the cost will be higher. This is the minimum cost that you can think of. So now how do you implement this thing? So basically we will use something that is known as priority queue. Okay, so once we have this priority queue in place, now whenever we talk about priority queue in Java, the elements, whenever you're trying to store elements in this, it will be treated as a min heap. So what do you mean by a min heap? If you're adding 5 4 3 2 1 in 5 4 3 2 1 in your 5 4 3 1 in your heap, it will be we don't care about rest of the elements, but the top of the element will be 1 when you're talking about min heap. So the minimum element will be there in the heap. So what I thought of, let's do this thing, let's do one thing. So let's dump all these values that are there in our array, let's dump all of these in our heap. So what we did, we dumped 2 5 4 and 1 and 7. We dumped all of these in our min heap. We don't care about rest of the values, but we know for sure the minimum element that will be on top of the optimal merge pattern. Yes, it's like, yeah, you can say that. Okay, So now what you're doing, you inserted all these in your priority queue, and the minimum element will be at the top. Rest of the elements, we don't care what is the pattern they follow. Okay. Now what you're doing, now we have this one, we removed it. We removed the one, and then again there will be the minimum element that will be at the top, and we removed this one as well. So that is why heap dot remove, heap dot remove. So what you did 1 and 2 was removed, right? And now you added them, and you have this temp over here. Now this temp will be act as a result. Okay, so what you will do, you added this temp, and you have this minimum, which will be the minimum sum, and this is the temporary value that you are getting every time when you remove two things. Okay, so you removed these two things and you inserted this into temp, that is the 3, and then the minimum value of minimum value is also 3. Now then the next step is that you have to add these two things back into the queue, the priority queue. So what happens now, these two are added, 3 is there. Now you have in your heap, you will be having 3, 5, 4 and 7. Now again you will remove these two, the value will be 7. You add this 7 to this sum, and then add this 7 back into the queue. So in your queue, what will be the elements? It will be 7, 4 and 7, 7, 4, 7, 5 and 7, right? Again remove two smaller elements with the help of this hashed heap dot remove and heap dot remove. 7 and 7 will be removed, right? And yeah, storing in the temp, right? Then this 5 and 7 will be removed. The value is 12. You added them in your this minimum value 12, and then again added them in their heap. Now you will be having 12 and 7 in your heap, removed both of them, and then added them, that is 19. So 19 is the value in your sum, in your min, right? Not sum, this is your min. Okay, so then you added back it in the queue, 19 is present in the queue. Now the heap size is not greater than 1, right? Heap size is 1. Okay, so now what you're doing, once you have that thing in your heap, so you can say if heap size is, will there be a situation where heap size is 0? Will there ever be a case when your heap size is 0? Quickly. No matter what you do, okay, even if you have, in this case you had 5 elements, right? In this case you have 5 elements in your array. Yeah, these are 5 elements. If you had 6, so let's take an example, 1, 2, 3, 4, 5 and 6. So 2 taken out, 1 inserted, 3 inserted, 2 taken out, 1 inserted, so 6 inserted, 2 taken out, 10 inserted, 2 taken out, 15 inserted, 2 taken out, 1 inserted. So no matter what you do, what will be the edge case here? So the last thing that you need to do is add this 19, remove this from the heap. So you write heap dot remove, and then add that thing in your min. So min plus min heap. So this is your edge case. You add you remove the last element and add that thing in your min and return, right? Yes. Okay, cool. Yes, Manju, you are correct, right? So then you return the min value, and that is how you implement this question. Okay guys, so this is it from this session. I hope you enjoyed this session. Once the session is over, go through it. I know this is a little bit I mean, some of the topics are simpler, but they are implemented at many positions. You can implement them, you can use them. Now this is a very important problem. The last problem that you just saw, it is a very important problem. So slide deck is shared with you guys. You can go through it and implement it. Okay guys, thank you so much guys. Thanks a lot for your time, and if you haven't subscribed to our channel, make sure you subscribe to our channel. Thank you so much. So next session we'll see when it can be scheduled. Okay, don't worry, Aishman. It will be notified. The last one is complex. No, Saksham. The last one is the most simpler one. You just need to think of it. So how you can minimize these things? How you can minimize? Sir, will you do any technical course? Manju, can you just rephrase it? What you mean? Do I take sessions on Java or anything? Yes, I do take sessions, right? And you already have a JavaScript course that is available on your YouTube channel, on our YouTube channel, right? If you haven't subscribed, make sure to subscribe to get all those things. Okay. So I didn't get the first three problems. Ashish Gupta says I didn't get the first three problems. You didn't get the factorial Fibonacci series problem, right? It was okay. The Catalan series. You just need to dry run it. Okay, just need to go through it again and again in order to understand what is happening. Okay. Okay, guys. Okay, thank you so much, guys. Thanks a lot. Thanks a lot, guys.